Well, hey there, welcome back. We are at Unit 3 now. This is Lesson 1, 3-1, there you can see at the bottom. And we're looking at GCF of Polynomials. GCF, do you remember what GCF stands for? Maybe you remember greatest common factor. One thing we'll look at each time is a math career, and here's one for you today. The chemist. The chemist you can see down here. Of course, chemists study composition of matter and its properties such as density, acidity, size, and shape, and so on. You can read this if you'd like. Just press pause there and you can read all about it. You can also see the salary. They give you a low, a median, and a high-end salary there, which is pretty generous. And you can also see the higher-end math that you need there to go ahead and go into chemistry. Pretty rewarding field there if it's something you enjoy doing. All right, remember, if there's a career that you have interest in learning about, leave me a note or send an email or something, drop a note on my desk or whatever, and I can be sure to get that information to you. Alright, so just as a reminder, if you see any of these, go ahead and check these icons here. You see the guy with the glasses, just go ahead and watch that one, write that, jot down some notes here, and put your practice problems in if you see this guy with the chalk. We're going to be jumping to Standard 11.0. We're going to apply basic factoring techniques, and we're going to learn all about that really quickly here. Today we will learn to find the GCF of polynomials. So maybe you remember what GCF means, greatest common factor, all the way back from 6th grade. I think you started seeing those. So here we have a list real quick, starting at the bottom, greatest common factor. Well, that's the biggest number that you can divide into two or more polynomials exactly. So if we were to take some little piece of a polynomial and we could extract something out, it would be the greatest common factor if we can take everything out, being the largest piece there. To factor is to break the polynomial into a product of its parts. We're also going to see that in just a second. And the factor is a noun. Well, that's just an integer that divides evenly without leaving a remainder. So, for example, the factors of 6 would be 1 and 6, 2, and 3. If you divide 6 by any one of those, the remainder is 0. All right, then. So, for example, the greatest common factor for 12 down here would be 12. Oh, I'm sorry. The greatest common factor for 12 and 18 is 6. I got stuck on the number 12 there. Is 6. 6 is the biggest common factor between the two numbers 12 and 18. If you were to factor 12, you can see the factors are underlined: 1 and 12, 2 and 6, 3 and 4. Those are the two numbers that multiply together to make 12. And finally, if you just were to list the factors as nouns, treating the factors, the word as a noun, you get 1, 2, 3, 4, 6, and 12. All right, you remember possibly this guy. A lot of my students remember this guy, Swiper. So before Swiper made it big on TV, he was just a common thief. When he robbed a group of individuals, he believed you should never take more from one group than you take from the others. So take a look at this particular problem. If you've got 4b minus 6, just watch. I'll go through this one here. Let's look at both pieces, the 4b and the negative 6. What's something they have in common there? Looks like they're both even. So if we factor out a 2, well, what you do is you end up writing down what's left. If you divide both 4b by the number 2 and you divide negative 6 by the number 2, you're left with 2b minus 3 here inside parentheses. And this that we took out here in red, this is the greatest common factor. So we look for what they have in common, and we essentially divide that out or pull it out to the front. All right, let's do this one together. Go ahead and add this one into your notes. What can Swiper take from this group? 4x squared minus 12x. 4x squared minus 12x. Well, look at the coefficients there, 4 and negative 12. Do you see they have a common factor of 4? And what else do both of these pieces have in common? Well, it looks like they have an x there as well. So we're going to be looking at removing a 4. So if we divide a 4 away, and what about an x? If we take an x out, you're going to see that we're going to reduce the exponents here by 1. And so what's left if we divide this guy by 4x and this piece by 4x? We're left with 4x times the quantity x minus 3. So what he's removing there is the GCF of that polynomial. So this is now considered in factored form right there. Okay. So why don't you try this one on your own? What can Swiper take from this group? 5m to the 5th minus 4m cubed. So if we consider 5 and 4, or negative 4 in this case, really those are what we call prime, uniquely prime. They really don't have anything in common with the number 1. So even if we divide by 1, we're still left with 5 and negative 4. But what about those letters M? How many M's can we remove? Can we take away 1 or 2 or maybe even 3 of them, right? So if we take away 3 of the M's, we take this M out front here, and that's what we factored out, and we end up with reducing the other M's down. And of course what he takes away is the GCF, so we're left with M cubed multiplied by 5M squared minus 4. And that's our final result right there. Alright, how about this one? 6x cubed plus 10x minus 10x squared. Now a little note here at the bottom, make sure your answer is in standard form. So maybe what we should do is write this in standard form now. So the textbook and a lot of your practice will give you problems like this. They're not in the proper order. So why don't we just rewrite that? We'll go ahead and move the negative 2x squared up front. And now look at each piece. What do they each have in common? If we just concentrate on the numbers there, the 6, the negative 2, the positive 10, those are all even numbers. So anytime you have even numbers, we can always take out a 2. What about the letters though? What else can we take out? Well, we can remove the letter x. So I'm going to go ahead and factor out a 2x. And now let's just mentally divide each piece by 2x. So 6x cubed divided by 2x, we end up with 3x squared. Notice we reduced the exponent by 1. We reduced the exponent by 1. And in this case, positive 10x divided by 2x will just leave you with a 5. 10 divided by 2 is 5, and the x's, of course, the 1x gets pulled out to the front there. So this is your final result right here. Alright, that's it for Unit 3-1. Make sure you have those jotted down inside your notes there. Maybe you write down a particular question for us for tomorrow. And if you need some more work, go ahead and take a look at what's there on your screen. Alright then, we'll talk to you soon.